I would like to explain the circle theorems. So how we will do this? I will show you the theorem and then I'll give you an example. So the first one here to the left is the angle on the circumference is always a right angle. So this angle down here is 90 degrees. If it's made on a diameter of the circle, that's a 90 degrees. So this is the first theorem. You should always know the angle on the circumference is 90 degrees on a semicircle. Alright? Now, look at this question to the right. This is how they will give you the question in the exam. The first thing they did to trick you is they didn't mention 90 degrees here. So you should know from the first theorem that this angle is 90 degrees. Now the question asks you to find this x. Now we know this is 29 and we know this is 90, so we can find x. So it's just 180 minus the sum of these two. 90 plus 29 is 119, and that gives you 61, I think. Now this is a correct way of doing it, but since this is 90, an easier way to find x is just 90 minus 29. That's also gives you 61. We finished with the first theorem. That's it. This is how the question will look like. Now let's go to the second one. This is it. It's a nice easy one. Now the second theorem says if two angles share the same arc, I'll just say arc, so they are sharing this, they both are built or they are made on this arc, they are equal. This is what the theorem says. Two angles sharing the same arc, they are equal. So if this is 50, this is also going to be 50. There is a condition though. They should be created or made on the same arc. Now this is a nice example here. So they ask you to find x here and they ask you to find y. Now I've noticed that 54 and x are both on this red arc. So that means x is just 54. That's it. Now I've also noticed y and 28 are on this arc here. So they are equal. So y is 28. They can try to be tricky and they ask you to find, for example, angle z here. If they ask you to do that, this is equal to this one here. So if you look at this triangle, this one, you have 54 and you have 28. If you do 180 minus the sum of these, you can get this angle. And if you get this angle, it's similar to that angle. And that's it. Now let's go to the third one. This repeats a lot in the exams. You will definitely see this in your exam, maybe. And let's see. Now, this says a central angle C here is double of the circumference angle if they again share the same arc, if they are built or created on the same arc. Now the question will look something like this is 70. What's this? So this is just double of 70, so it's 140. Or the question will give you the one inside the central angle. For example, they can tell you this one here is 150. Find x. X is half of 150, so it's 75. So if they give you the central, you half it to get the circumference. If they give you the circumference, you double it to get the central one. Look at this example here. There, we will get back to this again. We have another question on the same example. So if they ask you to find x here, this is a central angle 168 and this is a circumference angle, so it's half of 168. Half of 160 is 80, half of 8 is 4, so the answer is just 84. Ta-da! Finished. Now let's look at the next one. There is nothing to do on this. They just say First of all, this line, the line that touches the circle at just one point here, is called the tangent. So the theorem says the tangent makes a 90 degrees angle with the radius of the circle. So this is always going to be 90 degrees. We'll need to use this. So let's leave it for now. Let's go to the next one. It's easy. There is no way on which they can trick you here. It's just direct. Now look at this. There are many here. The first thing is, this is a tangent, and that's another tangent. These tangents meet at a point outside the circle. So from the previous one, we knew this is a right angle, right? If a tangent touches the circle, it makes a 90 degrees with the radius. So this is 90 degrees, and this is 90 degrees. We know this already. Now, the theorem says, once this tangent meets outside, they are equal. Can you imagine? This is a theorem. How easy. So they tell you this is 8 centimeters. Find this length. What is it? Oh, it's just 8 centimeters. How easy. Now, other important thing you need to know is this angle here, let's call it x, plus this angle there, let's call it y. They always add up to 180. X plus y equals 180. Now, if they tell you, for example, this is 30, find y. Y is just 180 minus 30. So it's 150. This is nice, isn't it? Now let's talk more about this. There are more things to say. Now here, the last part I would like to mention here is if we got a line comes from the center of the circle to the point where these oh, that's a perfect line. So if it comes to this point, this line bisect, it's a nice word, isn't it? Bisect this angle. What bisect means? Bisect means cuts this angle in half. So if this angle was 30 like before, if this was 30, so this line makes it to be 15 here and 15 there. That's it. All right. Now, what do you expect the question will look like in the exam? The question will then ask you to find this, find x. This is easy. We'll just look at this triangle. Follow me. I'll just make it green. We'll just look at this triangle here. Now we have 90. We have 15. We can find this. So it's just 180 minus 90 and minus 15. That's it. You can find it. Now let's look at the example. We talked a lot about this, right? Now look at this example. The question says find x here. To find x, I'll first do right 34 here because they are equal, right? I said this line cuts this into half, so that means this is 34 and this is also 34. And from the previous theorem, the tangent makes a 90 degrees with the radius, so this is 90. Now we have 90, we have 34. We can find x. You can just do 90 minus 34. It gives you x. I think that's 56. Or you can do 180 minus 90 minus 34. It also gives you 56. How easy. Now let's look at the next one. This is called the alternate angle theorem. It says this angle is equal to that angle, and similarly this one here, let's call it x, is equal to this angle y. So the question in the exam will look something like this is 50, find this one here. So this is just 50, and this is 60, find this one here. So that's just 60. How fun. Also, you may expect the exam question will ask you to find, for example, this one here. Let's call it A. If we look at this triangle, this nice triangle, you do know 50, you know 60, you can find this. Just do 180 minus the sum of these. and that gives you the angle. Now let's look at the last one here, and then we look at this example. Oh, this is a very nice one. This is called the cyclic quadrilateral. Cyclic. I don't know who thought of this name, but it's nice. Cyclic quadrilateral. So the cyclic quadrilateral is a four-sided shape. 1, 2, 3, four-sided shape inside of a circle. There is a very important condition. All the vertices, like the corners, should be on the circumference of the circle. Look at A, B, C, and D. They are all on the circumference. So if this happens, this is called cyclic quadrilateral. So what do you need to do with that? The cyclic quadrilateral, each two opposite angles add up to 180. So x plus this one makes 180. So if x is 80, this is just to be 100. They should add up to 180. So this is 80, that means this 100. Now if this is 50, for example, the opposite one, which is D here, is going to be 130. They add up to 180. And these also add up to 180. This is it. The question will look like, the question will look something like, I think there is a question here. Yeah, this one here. Let's do it. Now, one important thing to say is in the exam, you don't expect to just have one theorem in the exam, in the question. No, they will give you 2 or 3 of them in the same question. So you need to think carefully. Now let's do this question. The question asks to find x and y. I'll first use the central angle theorem. Do you remember? If you have two angles, one in the circumference and the other one in the center, and they are sharing the same arc, the central angle is double of the circumference. So if this is 70, x is double of 70, so it's 140. You got it. Now if we look at the cyclic quadrilateral, this is one point on the circumference, another point, a third point, a fourth. So this shape here is a cyclic quadrilateral. So this 70 and this y are opposite, so they add up to 180. So if that's 70, this is just 110. We got them. We got x and y, and that's it. How easy. One other important thing is you need to know the names, because sometimes they ask you to tell how did you get this. This is the last question I'll do, and that's it for the circle theorem. Alright, now the question asks you to find y. How can we find that? You can pause the video and try it. Now you know all the theorems, just give it a try. If you got it correct, that's perfect. If you don't get it correct, it's alright, you'll just practice, so please try it. Now I'll do it. The first thing is, this is a central angle, so I know this will be half of the central angle, right? So if this is 110, this is just 55. Do you get this? Now if we look at QRST, this quadrilateral, QRST, this is a cyclic quadrilateral. 55 plus angle Q here should be 180. So if this is 55, that will be 180 minus 55, which is 125. Now, look at this nice line here. This is a line, isn't it? That means 125 plus this makes 180. So this one here will again be 55. Because this is a line, if this is 125, this will be 180 minus 125, so it's 55. Now let's draw triangle PQT. Ta-da! This is it. PQT. This is a nice pen. Now this is 55 and this is 103. Can you find y? Alright, give it a try and comment your answer. That's all for today. I'll post another video for the circle theorems. I'll solve this question in that video. In the meantime, please give it a try, try to find the value of, they ask you to find which angle. Let me just look at the question. Angle ABD. So the question asks you to find this angle here. Please try it and comment your answer. Thank you for following. That's all for today. Bye.